I'm Miss Everly, math specialist of the elementary. 3rd through 5th grade focuses this year, and I am working on some 5th grade content with you. Unit 1, right now, what they're learning, real quick, just to give you an idea. Maybe you're like, oh yeah, okay, I've got it, all right? So I put up a humongo number up here, because that's what they're working with. They're working with pretty big numbers in 5th grade. They go all the way up to, let's look at the periods here, ones, thousands, millions, billions, okay? They go all the way up to the billions. So if you need to, you can check out a place value chart online to see within the periods what each one of these are called. But I have, just to give you an idea, ones, tens, hundreds, thousands, 10,000s, 100,000, millions, 10 millions, 100 millions, billions, 10 billions, 100 billions, okay? All right, so word form. It's going to take them forever to write it out. They're going to be like, it's exactly how you say this number. And some kids have a hard time just saying numbers. So if you practice something at home, it would just be writing out a number and saying to your child, say that number. See if they can do it. And then better than that, can they write it down in word form? So I have here 8. So you want to look at the period. 876, and what period are we in? Billion. Okay? Comma. Now I go to the next period. That's a 400 in that period. But what period am I in? I'm in the million. Comma. And then there's nothing else. So this is my number. So I'd actually leave out that comma. Okay? So they're working on taking a number and being able to write it. Next thing to be able to do with it is take that number, and the teacher, or maybe some student, will highlight or underline a certain digit in that number, like the 7. And I'd say in that number, 876 billion, 400 million, what is the 7 worth? What is its value? Is it just worth 7? No, that would be 7 ones. That would be way the heck down there. Since it's way over here, I'd have to ask myself, what place value is that in? Well, it's not in the ones, it's not in the thousands, the millions, it's in the billions. So is it worth 7 billion? It's close. It's actually 1 away from the billion. It's 10 billion. 7 10 billions. So how do you write that? Well, 10 billion looks like this. Right? And we have 7 of those. So if we have 7 of those, I need 7 of those, which would just be 70 billion. And as you can see, these numbers here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just all become zeros. How about the 7 in this number? What is it worth? Is it also worth 70 billion? What do you think of? Well, no, because it's not in the billions period. What period is it in? Is it in the ones? No. It's in the thousands. So is it worth 7,000? Thousands. Yes. And that would just be 7, 0, 0, 0. Because these just become zeros. And you might be like, they're already zeros. Yeah, you're right, they're already zeros. Okay? So looking at value. Next idea is being able to take 2 big numbers and be able to compare them. And comparing, we use what's called inequalities. This one's the less than sign, then we have the greater than sign, and then we have the equal sign. So we look at 2 numbers, compare them, and say, well, why? Why is that one greater than, or why is that one less? That's the most important part, figuring out why. So if we look at these 2 numbers, what I noticed right away, and what the kids should notice right away, is they have the same amount of digits. They both have 7 digits. So if they both have the same amount of digits, then I can get into comparing those digits. And I work from left to right. So I'm going to start with the 2's. And you know what? Those are the same. So I have to move on. So I'm going to go to the next digit in line. And in this case, it's an 8 compared with an 8. Oh my gosh, they're the same again. So I have to keep going. I work my way right. And I don't just say, oh, I'm going to skip to the 7. No, you have to go in order. So I'm going to go to the 7 and compare it with the 2. All right, finally, we have two different numbers. And I can see that the 7 is bigger than the 2. So now I can say that this number is greater than this. Because, why is that? It's because the 7, and what place is that in? Thousands. It's in the thousands period, but it's the 10,000s. 7 10,000s is greater than 2 10,000s. Okay? And that's how I know that this big number, 2,876,547, is greater than 2,826,547. Comparing numbers. All right, now we're going to take it a step further, 5th grade. Now we're going to look at decimals. We're talking things that attach on that aren't whole numbers. And in 5th grade, we work all the way to the millionths. Okay? So, if I go to the right of the decimal, I'm now at 1/10. That's worth a 10th. And I'm going to use that here. Then I go to 1/100th. That's this value. So that's a 100th. Then I'm at 1,000th. And then I'm at 1/10,000th. And then I'm at 1/100,000th. Okay? 10th, 100th, 1,000th, 10,000th, 100,000th. That should be pointing to the 2. And the 6 takes us to 1,000,000th. So this number, how we write it in word form, I'm going to have 8 whole numbers, 8 ones, 8, and then there's a decimal point. We don't say decimal point, we say and. So 8 and, now I'm going to look at this number as a whole chunk. So what number is this? Well, those don't even count. I look at this. This is just 26 sitting there. So I'm going to have 8 and 26. And then I would report out what place value this 6 is in. And in this case, as we went through all of it, it is in the millionths. Millionths. And if you have to, just look up a place value chart to see that. All right. Let's try saying these ones. Maybe pause the video and try it yourself. But this is 7 and 49 hundredths. Then I'm at 2 and 241 thousandths. This one I'm at 3 and 24 10,000ths. In this case, I was stepping it up and saying, tell me the value of the underlined digit. In this case, I have highlighted the same digit in each one of these numbers. They're the digit of 4. I have 4, the number 4. The number 4 here represents a different value than the number 4 here and here. In this case, the 4 does not represent 4. It doesn't represent 4 ones. It is behind the decimal, to the right of the decimal. And that is worth 4 tenths, or 0.4. And if I think in money, that's 40 cents. Okay, if I go here, this 4 does not represent 4 ones. It represents tenths, hundredths, which is 0.04. I'm going to now make that 2 into a 0, and that 4 is worth 0.04. So now which one is more? Well, the 0.4, because that's 40 cents, whereas this is 4 cents, if I'm thinking in money. If I go to this last one, the 4 here is worth what? Not tenths, hundredths, thousands, but 10,000. So if I write that number out, I'm going to replace these three numbers in front of it, or I can replace all of them. That makes it feel better. 3 becomes 0. 0.0004. So that isn't even worth a penny. Okay? All right, so value of digits. Okay, and then we take decimals just a little bit further and compare them. So let's say we have 8 and 45 hundredths and 8 and 47 hundredths. We're going to compare it with inequalities. This being the less than sign, then we have the greater than sign, and the equal to. You can already tell these aren't equal. Okay, they're not the exact same number. Do they have the same amount of digits? Yeah, this one has 3, that one has 3. I could line it up vertically and get my decimals to line up. So I have 8.45 and line up the decimal here, 8.47. That helps a lot. Now I can kind of see it in 3 groups. And then I just work from left to right. 8s are the same. So I go through that. 4s are the same. So I go through that. The 5 and the 7 are different. So now I can determine that this 5 is less than that 7. So I can say that that number is less than this. And why is that the most important part? Why? Well, we looked here, but what were we looking at? Why? Because 5 hundredths with the TH is less than 7 hundredths. Okay? So we really want to determine why things are what they are. Okay, let's look at these. If I line them up, compare just a little bit more. 0.584, 0.58. Same, same, same. Oh, well, what's happening there? There's nothing there. Except for a 0 there. Now we have 2 different numbers. 4 is bigger than 0, so I have greater than. And why is this number greater than that? Because 4 thousandths is greater than 0 thousandths. Okay, let's look at one more. This one messes kids up all day long, every day. Okay? I have 5.2 and 5.20. 5s are the same. 2s are the same. And then I come to this. What's happening there? Well, if there's nothing there, replace it with a 0. And oh my gosh, those are the same. So what does that mean about these numbers? They're equal. And why is that? Because there is nothing here in the hundredths, which means the same thing as having 0 in the hundredths. And that is the main idea that kids are learning in Unit 1 of